Hey there, viewers, welcome back to the Self-Made Auto Channel. Got us our 2008 Suzuki XL7. It's got the big 3.6 in it. It was towed in today on a trailer. The guy brought it in, told me it had a camshaft sensor problem, and what he has done is he bought a new camshaft sensor. Now this engine has 4 of them. He did, I guess he played hopscotch with it, put it in one hole, cranked it, put in another one, another one, did all 4 of them. The code always came back and the vehicle never started. It cranks okay. So I thought, well, we'll start fresh. We'll see what's going on with it. First thing I did is pulled codes out of it. And I was having a heck of a time getting a scan tool to work with it. My OTC didn't work. The Altel didn't work. The little launch works, but I ended up going to generic OBD2 data because OEM specific, it just wasn't working. Needless to say, it does have a couple codes in it, but nothing to do with the camshaft sensor. So you can see we have the P0335 crankshaft position sensor A circuit, current and pending, and the vehicle is a crank no start. I assume it does not have any spark or injector pulse. So what I want to do is bring you guys along. We're going to test the crankshaft sensor, Hall effect style sensor, 3 wires, 5 volt signal wire, and then a ground. However, I've discovered that it is 100% inaccessible, and that really sucks. It's all-wheel drive, so you have the power transfer unit underneath. The crank sensor is in the back side of the block. I believe that's bank 1. And it has a shield over top of it, and it's about dead center of the engine. I can't reach it, I can't touch it, I can see it. I'm thinking if we are gonna end up needing to get to it, I'm gonna have to pull the wheel, pull the tie rod in, and then reach my hand in behind the catalytic converter to get the 2 bolts off the shield and get it out. So with that being said, I think our best testing method is going to be there at the ECM. It's not the best place. It is where the signal has to eventually make it to, but that doesn't allow me to go down and say, is it a pin fitment issue? Is our 5 volt reference making it to the sensor? Is the ground making it to the sensor? We'll do as many checks as we can here, and then I'm going to have to get permission from the customer. Assuming we don't have a signal here, we're going to have to get permission from him to, spend some more time with it to get down there and say, well, crank sensor is faulty, or connector or something like that. I tried to do the best visual inspection I could, and I don't see anything down there, but again, you can't really reach it. I know that's a lot of mumbo jumbo, but it's late. I'm not trying to make excuses. That son of a gun is buried. I did look us up a wiring diagram here. What is it? It goes into connector X1. Get my little diagram to open up, which I believe is the bigger connector. Let's see, 96 pin connector. So it's going to be this little guy. Let me shut the key off. The key is off. And we're going to open this. Potentially. Well, how in the heck? Let's get this cover off this ECM first. So we can see what the heck we're doing. Yeah, I don't know why my scan tools were acting so pissy on this thing, but when I hooked up the OTC, it wouldn't read any data. It just defaulted right to generic. The Altel, it just locked it up. And then the launch, it was it took a really long time to read the VIN number. It was just acting super weird. These little gear latches can be a pain in the neck sometimes. They get out of time or they don't grab correctly. Sometimes you got to kind of help them along a little bit. There we go. I just want to get it up enough to get this cover off, which that can be a pain in and of itself because you want to get it off, but you don't want to break it. This side's already, it looks like it's, no, that's not broke, never mind. I was making excuses before I broke it. We'll get a little pick. I'll zoom you in. Enhance. Enhance. There. See? No excuses needed. Alright, now we can lock it back in. It is fully seated. We'll see if we can leave the zip tie on there. Let's figure out, that's what our connector looks like. Let's see, we do not want to enter tablet mode. And then the wiring. Come on, why won't you listen to me? Freaking ding dong. Want to see a frisbee? I'm not gonna frisbee it. There we go. Sometimes you gotta slow down there, little buddy. So here we are. There's our cam sensors. Here's our crank sensor. X1 pin 45, 35, and 46. 35, 45, 46. 20. Okay, let's find them. So cut the zip tie. Some of these connectors are really tricky to back probe. And with circuits that tight together, sometimes you're best to not back probe. You can accidentally come across two of them. And depending on which two it is, that could be a bad day. So we're going to take and just open up this loom a little bit here. We'll come back and put this just like it was from the factory. So don't sweat that. Alright, rolling down. Now we know what we're looking for. So 45 and 45 should be on this side. 1, 2, 48, 47, 46, 45. 1, 2. Now, there's our gray wire. What's up, Marie?
Hey.
Okay, so there's our gray wire. That should be our 5-volt reference. We'll leave that out in the open. If you're not into doing the hokey pokey, cover your eyes. We're doing the hokey pokey in a spot that can be repaired, so don't fret. If you're using these probes, just crank it in just till you feel it break the insulation and stop. 45, and then right next to that we need 46, which is on the front side of that. There's a lot of tan wires here, so make sure you're getting the right one. 8, 47, 46, that should be this wire right here. I got hooked to my finger. That should be our ground. So we'll grab that one. Okay, and then last but not least, the yellow wire, the signal wire, number 35. So that's 24, 25, 26, 27, 28, 29, 30. Oops, dang it, I pushed the button too long. I'm losing my freaking mind here. 24, 25, 30, 30. To be right about smack in the middle of that connector on the same row. Hopefully it's the only yellow wire so we don't have to count. And it is not. There's 2 yellow wires. So now we have to count. Let me get a pointing device. So 25, where are we going for? 35. 35, 26, 27, 35.
Where am I?
That yellow wire. Right? Yeah. Let's fish that up through where we can get to it. I accidentally grabbed 2 of them. They have to both be yellow. It's that yellow wire. Okay. Alright, that's our signal wire. But it seems a little testy, folks. I'm just tired. It's late. Is that a good excuse, Marie?
No.
To be testy. There's that. Okay. So now we're all hooked up. So now, when you're doing testing, you have to know what you're going to expect to see. This car has a 58 tooth reluctor wheel. It's actually a 60. It'd be a 60 minus 2, we'll call it. They're 6 degrees apart, and then your bigger gap is 12 degrees apart. So when we crank it, we should see 58 teeth from 0 to 5 volts, square waveform. I'm just babbling at this point. We should see 5 volts. We should have a good sensor ground, and then of course our signal wire. If the crank sensor is good, then we'll see a signal. If not, it may be high, it may be low, it may be at 5 volts or at 0 volts. personally, I suspect we're not going to see anything on the signal wire, but hopefully a good 5 volts in ground. And then if that's the case, like I say, we're going to have to move on and get permission from the customer to spend some time on the old girl. The good news is we get to play with our new toy, which we've already revealed. The AES Wave uScope, a full functioning, 1-channel digital storage oscilloscope.
Sweet.
That you can wear like a little wristwatch. So we use that.
It's very fashionable.
It's tiny, isn't that awesome?
From my perspective of watches, it's a little large for my style.
For a watch, yeah, but for a scope, I mean, considering this is my other one.
Oh, yeah.
This thing's like a little mini one. We turn the key on your lady.
Yep.
First thing first, we're going to check. So we've got our scope set up on 2 volts per division and 5 milliseconds. Let me change. You can go ahead and shut the door, Marie. I change it to 1 volt per division. So if we have 5 volts, it should go up 5 divisions on our scope here. So we will check the 5 volt reference in the ground. I forget who's who. 5 volts is going to be gray. Bambino. Why is it making noise on me? Alright, let me pull up a cursor here. Okay, that's a coincidence. Okay, I might grab a cursor. Oops. Oops, wrong button. Gotta remember how to do this. Okay. I did not bring up the cursors. I brought up the meter section so we can see our volts. Volt min, volt max, volt average is 5.08 volts. So we're at the 5 volt mark. And if this, hopefully you guys can see this, if this green mark is 0, we go up 1, 2, 3, 4, 5 divisions. So we're at 5 volts. Okay, so we have our 5 volt reference. We have our ground. Now, we need to take our signal wire. We need to plug into that. And that currently is residing at 3 volts. Let me change. Let me back out of here. Gotta remember how to use this thing. I'm gonna put a lot of time on the screen here. We'll put it on 1 second per division. We'll have Miss Marie crank it over, and if the sensor works, we're gonna see it working. So just go ahead, just hit the key. It's gonna crank on its own. Okay, that's interesting. All right, just a minute. Let me change some settings here on the scope. Figure out how to hold it. Hold. There we go. Okay, go ahead and crank it, Marie. Okay, there we go. So there's our capture. I probably should familiarize myself with this little fella first. I do not believe that so this is kind of interesting. So look at that. So there's our square wave. I'm not familiar enough with the tool to go back through and replay it, but we can see this. Let me show you what the problem is here. Oops. Let's see. You know what? Here, I'm gonna pause this. I gotta get out my cursors. I'm gonna show you what's going on there. Even though that looks good, it's not. So I turned on a cursor. Now it's hard to see on that screen, but we can see up at the top screen. Hopefully you kind of hard time holding this and showing you. But our cursor at the peak of our waveform is only 2.12 volts. Our signal, as I mentioned, should be going from 0 to 5. So it appears the crankshaft sensor is working, but not at its full amplitude, which is pretty interesting. I was hoping we could see. I gotta fiddle with this thing more before I do videos on it. Crank it over again for me, Marie. I just want to see if I can pause it and zoom in on it here. Okay, that's good. Let's see here. No, I can only zoom in on what was on the screen. Actually, the peak voltage that time went even lower, so under 2 volts. Long story short, at this point, we got to get to the crank sensor. The only thing we can do is we'll make sure that when she's cranking it, we are not losing the 5 volt reference and not losing the ground. So right now our green trace, let me see here, I'm sorry for this video, folks. We'll get some time on the screen here. So our green trace coming across is at 5 volts. Go ahead and crank it, Marie. That's good. So we did not lose 5 volts. We did not lose our ground. However, our signal coming back from the crankshaft sensor is just that. It's not reading the correct amplitude. Chances are we're going to have a shorted out crankshaft sensor. Okay. All right. All right, folks, so I'm going to leave it at this for right now. We could see on the uScope, even though I don't know how to fully function it at all yet, I still have to read the instructions. We could clearly see that we have signal 0 to 2 volts. Unfortunately, that's not crossing the threshold of which the ECM looks for in order for it to, start the firing sequence. So use that as a learning lesson when you're looking at waveforms and you know what a, say, Hall effect sensor looks like. Just even if you don't know how many teeth are on the crankshaft, you're supposed to see the square, square volt or square waveform. Also look at your values. Is it 0 to 5 volts? Is it the full amplitude of the signal, or 0 to 12 or 0 to 8? How's that sensor work? So you know what to be looking for, not just the pretty picture, which we had a nice looking, halfway decent looking. The tops of them were kind of chopped off. And that's it. And also on this one, we checked the 5 volt in the ground to make sure that was not being diminished as we were cranking, because certainly if the 5 volt was going away or the ground, that's going to goof up our signal. The only thing we have to do now is be able to get to the crankshaft sensor, and it's kind of late, so I'm not going to call this guy. We'll check that out tomorrow, because I suppose if there was some, resistance in the 5 volt wire down to there where it's only receiving 2 of the 5 volts being supplied to it, then, now there's a problem. Or it could be just a faulty sensor. So if we get down there, we've got 5 volts of ground and it's still, throwing out this 2 volt signal, then at that point it's a crankshaft sensor, so no big deal. And I guess that's it. Not really a great video for me. I'm tired and I get a little grumpy when I get tired and it's late and I want to go home. So that's what we're going to do. Pick up on this. Probably be a part 2 of this video. I'm sure the guy's going to fix it. I doubt he'll just junk this car over something like that. It does not look like it's going to be fun to do in either case. So if you want to make sure you see part 2 of this video, assuming there is one, go down, click subscribe, ring the bell so you get notified. And just remember, viewers, if I can do it, you can do it. Thanks for watching.